Now, wind energy, to some extent, requires a very good wind.
Which we have or we don't?
We have air.
We have air, not wind.
Yeah, we have a lot of air.
I heard Ghana is building a new one, the Polugu Dam.
Polugu, yeah.
Yeah. So how are we going to do that, considering the cost, the unit cost, if it's going to be this high?
Okay, Polugu project has been on the table for a long time. Feasibility studies have started long ago.
Okay.
And we have even reviewed the feasibility studies again and again and again. So it's a project that has started before. So we're getting to a point where it has to be built, financed and built. So after the financing and building, depends on who gives you money and the kind of...
Do we have that already, the financing?
I don't know, but I don't think so.
Okay.
I'm sure if we had it, we would have built
off.
it by now, but I don't know. I don't want to say I know, I don't know. So, but we'll build it.
Okay.
Now, the Polugu project was also fashioned in a way that they attach irrigation to it.
Oh, okay.
So it's not just for electricity, but for electricity and agriculture. So you're kind of making good use of the water. So you are making revenue from electricity, you are making revenue
from the agricultural
So in that case, it's easy for you to justify the cost of the project. Even though it's expensive, you get revenue from electricity, you get revenue from agric, then it works very well.
Okay. And what's the megawatts?
49 megawatts.
Okay.
So the Polugu project is about 49 megawatts.
Okay, okay. So at least there's an addition there that can add to the mix for us.
Yeah.
Okay. But what of the biomass? You mentioned that biomass is very minimal now.
Yes. Biomass is not being produced at an industrial scale now in Ghana. It's individuals who produce biomass for themselves. Okay. If you have a means of producing the methane, it's all gas. Biomass is predominantly gas.
Yeah.
Trying to produce your own gas from your own biomass.
That's it.
And then you use the gas to power a generator. It's like going to buy natural gas to come and power a generator, but you produce your own gas.
But you know, I think in Korea,
yes,
they do it commercially, so everybody's just comes to the same place, and then it's.
So maybe Zoom Lion can do that.
Can consider that. I'm sure they can, because they are doing amazing with recycle of anything.
They can easily do it because they have that volume of waste to be able to do the biomass. So
Zoom Lion, if you're watching, this is a pick for you.
I'm pretty sure they've considered it, but just that like the economics of the project will have to be looked at very well to ensure that what you put in,
you get it
out.
Get it out.
Yes.
Because waste is not always waste, you know.
You're right.
You can always, I mean, turn it around.
Yeah.
Okay, so now I understand that though Ghana has so much sun, it's not just about having the sun to have solar going. So the technology and the cost of making the panel. But you know we are producing solar panels in Ghana now.
I know.
Yeah.
But in just small quantities.
Yeah, because we spoke to a company, SPS in Tema, and then they are, I mean, into that now. So at least that could bring down the cost of getting a panel.
I hope so.
Right.
I hope so. It's a matter of just checking the cost of their panels and check the cost of an imported
from the
panel.
international market.
I hope that our prices are lower than what is imported.
Then
that would be excellent.
It can get.
But if it's higher than what is imported, we are still in trouble.
Okay, so in all the mix that you have discussed now, there's been no mention of nuclear energy, nuclear power. Why has Ghana not considered it? Okay,
nuclear technology is a very good energy, to be honest with you. Nuclear energy is a bit of a delicate process because nuclear produces the radioactivity, the radioactive nature of nuclear. And it requires a lot of care and safety to run a nuclear technology.
Of course.
And nuclear is not for, excuse me to say, careless people. It's for very careful people. Okay? Now, nuclear plants in previous times have always come in huge capacities. 1,000 megawatts, 2,000 megawatts, one plant, one machine.
Then automatically it would propel the industry.
That is true. But you see, when you start a nuclear plant, because the nuclear reaction is always continuous, you can't stop it. So that plant has to run 24/7. Now, if you have a 2,000 megawatt nuclear plant running, you are supplying to a load of about 3,000. That is the peak load, the highest load. In the night, when everybody is asleep, that load can come down below 2,000. Because people have switched off, people are sleeping. Now, when it comes below 2,000, the nuclear plant will still produce
the same 2,000.
amount. So the question is, that excess production, what do you do with it? Okay. In some countries, what they do is that they supply the excess power to the hydro plants, and they use that power to pump water from the tail race back into the intake. So they make use of
there's that connectivity.
There's that connectivity. But what I'm saying is this: nuclear has always been a very delicate technology. The capacity for our system at that time, when it was just about 2,000, 3,000 megawatts peak, nuclear machine wasn't the best option because just one machine could have been enough. And we also had a Kosombo on standby. Fast forward now, nuclear technology comes in smaller units now. 100 megawatts, 200 megawatts. We can build it. And to be honest with you, the nuclear team in Ghana have started serious work to build a nuclear plant.
To put it together.
The other problem is about safety of the nuclear material. We need to be sure that we are well trained to be able to handle that nuclear material. Now, even after you finish using that nuclear material, the waste is enough for somebody to use for something else. So it means that when you finish using it, you have to find a way to take it away so that nobody gets access to it. Now, what I know some countries do is that they employ for people to give them the material, and when they finish using it, the people will take it back.
Take it back?
Yes, it comes in, you use it,
and just return it.
Just return it, yes.
Then we can consider saying.
These are options, though. So it's making it easier for us to manage. But that doesn't take away the fact that the people who operate the nuclear facility should be on top of their game. Because if you make a little
train
mistake
and prepare. So
the nuclear, if it leaks, we are in trouble.
Then we are all gone.
So that is why people don't want to even hear
about the nuclear,
because the devastating effect of the radiation is difficult.
Of course, all technology has its pros and cons. So I'm sure there are ways. If other countries are benefiting of it, we should be able to find some way. You know, when the hydro power was first set up, we equally produced an excess. That was when Valco was set up and all that. So if we want to go into nuclear, and one of the issues about the mass, then we should get industry to develop alongside it.
I mean, in Africa, if anybody is able to, within the West African sub-region, if anybody is able to build a very good facility, it's about the unit cost. If the cost of the facility
the cost is high.
It takes a lot of money to build a nuclear plant. It takes a lot of money to run it because of the safety concerns. So all this is added to the cost, and it drives the unit cost. If the unit cost is better, than the thermal plants and
Oh, the
all
unit
those.
cost, can it be better?
Oh, it can.
Okay.
I mean, it all depends on how you source your funding and how you operate your plant.
Because if it's that powerful, then, well, you could get the expertise that could raise the price, but that all the excess Ghana can be exporting
Sure.
and sell
Sure.
all
I
around.
mean, and exporting power, it's a good option. It has to be looked at from various perspectives. I mean, for years, Ghana was exporting power to Togo, Benin,
Yeah,
and it was part of the Akosombo Agreement,
yeah.
actually, because there was a need to send power to Togo, Benin.
Okay.
That's how come we built a line to them. But you know, when we are short of water and we are shedding load,
Yeah.
we want to shed.
How do you give
We want
them
to shed them.
what you don't have?
So when you want to sell power to your neighboring countries, you should be able to respect the contracts that go with it.
Yeah.
So that when you have a problem with your supply, you don't say that because I don't have, I won't give you.
I can't give you.
If-
But really, you can't give what you don't have.
well,
You know.
agreement is an agreement. So, and it's all factored into the agreement one way or the other.
That's true. So I think it should more have to do with the kind of agreements that we
you
go
sign
into.
with your customers,
Yeah.
yes.
So, you said nothing about wind energy yet.
Yes, I haven't because we are still developing the wind technology in Ghana. Even though it's a developed technology in other parts of the world.
Yeah.
Now, wind energy, to some extent, requires a very good wind.
Which we have or we don't.
We have air.
We have air, not wind.
Yeah, we have a lot of air. Wind technology is already being developed in Ghana. Now, to get a proper wind energy, you need to have a constant flow of wind in that area. There are certain parts of this country where the wind is always blowing very
Is that in the north?
No, we have areas in the Volta region.
Oh.
It's normally in the coastal areas and in the flat plain areas, yeah, of wind blowing very well. So what is being done now is that we have mounted what we call wind monitors
Okay.
in some of these areas, and we've been monitoring the wind for years now. Yeah, that is normal for any development of a power plant. Make sure that the resource is available for years to come.
You make the attempt.
So eventually for Akosombo, they had to study the flow of the river from 1939.
Oh.
They checked the flow for a long time.
Research is always essential.
And they were sure that this river, when we build a dam on it,
it will not fail.
it will not fail. Tomorrow the water will not vanish. The same way, you measure the wind and make sure that the wind is available for a very long time. So these measurements are going on. You need to have a minimum of about 4 meters per second wind. Now, if that is marked as, okay, now this area, on the average, we can get 4.
Yeah.
Then you begin to develop the technology and have it in place.
Around it.
Otherwise, you put the wind turbine there, it blows for 30 minutes and it stops.
So you do not get the essential
Exactly.
results.
Exactly.
But we read something online about VRE doing some partnership that is supposed to bring us wind energy.
Sure.
So that's on.
VRE has always been planning to build about 120 megawatts of wind.
Oh, wind, okay.
In 2 phases. And that's how come I mentioned that they've been doing a lot of
research,
studies, taking data, and just being sure that the site where they are earmarking for the project is suitable for now into the life of the project, so that you don't just go halfway, then you don't have wind again. So that's being done. And then because I know VRA may not be able to produce all the money required to build the project. They want to partner others who have the money
which is
and the
ideal.
technology to build it so that we have it.
Okay. So a very important question I wanted to ask. We always wonder, that's the worry of the everyday Ghanaian. Why do we sometimes have these power cuts? I mean, some planned, some not planned, and it's been forever. So
Good, that's a very good question. The power value chain, we have production,
okay,
and then we have transmission, and then distribution. I'll explain for the common understanding. Now, electricity, when it is produced at the plant, it needs to be sent to the user. Now, if you don't send it well, you will lose all the energy
in between.
Electricity has two components that run it, voltage and current. Okay? You're familiar with these terms, voltage and current. Now, if you want to send electricity over a long distance, you will have to raise the voltage.
Okay.
And when you raise the voltage, naturally the current becomes small, relatively. Then when you send the power, because power is voltage and
go
current.
all the way.
You can go because you won't lose. Current is small, you can go, okay? Now, as we raise the voltage and we send, we are transmitting that power. That is the transmission side of it. Now, when it gets to the other end, because that high voltage cannot come into individual houses,
directly,
we'll have to reduce the voltage. To bring it down, the current will go up, and that is distribution.
Oh, so it's all received at a particular level before redistribution.
That is why we have places we call substation, Achimota substation, Winneba substation.
We hear a lot of it when
those are the points where the transmission ends, and then distribution starts from there. Okay, so what am I trying to say? Now, if for any reason there isn't enough production, the consumer will not get power.
Of course.
If there's enough production, but the lines, the transmission lines, are not good enough
to receive,
you can't send
and transmit,
the consumer will still suffer. If the transmission is good, but the distribution lines are also not good, you have problem. So you see, any of these three can create the problem you're talking about. It gets worse when all the three play together. Bad production, bad transmission, bad distribution. But it doesn't normally happen. But that is what happens in a particular situation. In Ghana, most of the time, the production is just around what we need. Once in a while, it goes slightly below when there's a problem, maybe with gas supply, or maybe some fuel is not ready, or maybe the dam
goes down.
Just a small. Transmission is there. But when the lines are loaded, it gets to a point that you need to have adequate lines to carry. Now, if for any reason one line is not available, the remaining lines may carry, but may not want to carry for too long, and they also give up. So the reliability also comes to play. The same happens in distribution. So these ones are the causes of, and I'm talking purely from the perspective of high-level situation, transmission, generation, distribution. I'm not talking of little things like the line in front of your house, some tree has fallen on top. No, that's not what I'm talking about.
Different.
I'm talking of high-level matters. But this is also complementing the problems we have locally. Somebody's tree has fallen on your line.
Yes, it happens.
Something.
So I wonder if in other countries they have that connection on ground.
On the ground.
Are we not able to consider that in new or developing areas that it has not already been put up?
We have some underground cables in distribution.
Okay.
We do have. And you realize that sometimes you see people digging alongside them
ground.
putting some red or blue lines.
Yeah,
You've seen
I've
that.
noticed
Yeah,
that
those are
in
distribution
developing
lines
areas.
being buried underground.
But
when
which is appropriate? Which
they all
helps
have their
us
pros
better?
and cons, okay?
Okay.
Now, if a line is overhead and for some reason it breaks,
Mm-hmm.
you can see this is where the line has fallen. You quickly go there
Go and fix
check
it.
it. If an underground cable breaks, you need a sensor
To go
to
all
check
around
and see
to
where
check.
the break is. Otherwise, you have to dig the whole place and get
Wow.
the line out. So they all have their pros and cons. So it depends on what you want.
In terms of modernity, social development, the beauty of an area, you'd always prefer it all clean in the sky and then would go down.
Yeah, that is ideally the way it should be. We will get there. I mean, as it becomes more of an eyesore to see lines running all over the place.
Some areas you get there and
exactly,
the sky is full.
Some policy may drive the need for us to put the cables down. Because maybe the country planners would then decide that, look, we don't want to see these things. Find a way to give us our power, but don't be running it.
Is it more expensive if it's down?
It is.
It is more
Underground
expensive.
cables
cost more.
Yeah, they cost more. They're much heavier and they cost more. The infrastructure costs more.
Okay. But I think, I mean, anything is possible when it's planned for.
Definitely.
So
There's
why
nothing
not?
that is impossible.
Yeah, so we should, so that we clear up the skies, really. I'm sure environmentalists are also, I mean, looking at that aspect, because even the birds go there and get hurt, so.
That's why as professionals, we need to think wider than
far and beyond.
To think far and beyond. I keep asking myself that if tomorrow everybody decides to have his or her own solar panel, what happens to the huge plants that we have?
That's a really big question.
Yeah.
But if within the country that happens, can exports be an option altogether
frees a lot of
for
power
us?
for industry.
Okay.
It frees a lot of power for industry. Okay. Yeah. Frees a lot, but don't forget that technology, the industrial people will also
Also
love to
moving
have
on.
control over
Yes,
their
it's
power.
not just domestic. But
So
well, that could take a while.
this world.
We didn't see AI coming yesterday.
Oh, the world is moving so fast.
Yes.
While some time ago was plenty years.
Yeah, that's true.
While now could be just 2 years.
But the kind of technologies we see now, we used to see in movies. You watch Matrix and you see things happening, and
they're coming so fast now.
Everything is a reality now.
Sure.
Well, I think we've had a great conversation. I've really enjoyed this, and I've learned a lot. I'm sure my viewers have learned so much too. But you definitely have that little thing we haven't addressed yet. I want that to be your last words, and then tell my viewers of that.
Well, electricity or energy, I would say for that matter, is getting expensive every day. And it would be very good for us to use it judiciously. Energy is not cheap because what goes into producing the energy is very expensive. And if it's produced for you, you have to use it well and also pay for it. Yeah. Because if you don't pay for it, there will be no money
to produce
the
again.
next one for you. Yeah. So I know that is tough in this country in terms of money.
Yeah.
But one thing I keep telling people is that if you look at the amount of money you spend on communication and what you get out of communication, and you look at the amount of money you spend on electricity and what you get out of electricity,
better
I think we should learn to put the money at the right place to get the beneficial product.
Yeah.
That's what I'll say.
Thank you. Thank you very, very much. And those last words are exactly what we need to hear, because it goes all around to affect the individual, it affects industry, it affects us tomorrow, and it affects our present economy, actually.
Sure.
So thank you so much for making time with us.
You're welcome.
To our lovely viewers, thank you for spending your time with us as well. If you have not subscribed, kindly go ahead and do that now. Just go down and click the subscribe button, and do click the bell as well, so you will be notified whenever we have the next episode on. So, as usual, this is what we do on Energy Quest. We demystify the energy sector and add value. So we meet again. Ciao.